Here's one simple problem on axial deformation, and I wanted to start with this one because I think it's important to know the basics and how the signs work before we get into more complicated ones. So this question asks to determine the displacement of ND with respect to end A, given that the diameters of all of them are different, they're given, and E equals 18 times 10 to the third. So let's start off by basically piecing everything together. We know that the equation for displacement is PL over AE, where P is the force, the normal force, L is the length of that segment, A is the area of the segment, and E is the elastic modulus, which is given. So we know that from end A to end D we have three separate chunks, AB, BC, and CD. So to find the whole AD, we need to find the individual ones and then simply sum them together to get the final answer, or the total displacement from A to D. So I started off from this end right here, and I cut somewhere around here on this beam. So then I just did the sum of the forces in the x direction, and I got N to be -8 kips. So then I just plug it straight into my equation. I put -8 times the 80 inches right here over the area, which is pi r squared, times E, which is given, and I got -0.0805 inches. So now I found my AB. Pretty simple. Then we go to the second segment. So for the second segment, we cut somewhere along here, and you could consider either from here to the cut or from this side to the cut. Either way, you'll get the same answer, but I considered starting from point A. So here's my cut. I have my 8 kips there and my 2 5 kips. So N plus 8 minus 5 equals 0. So in the end, N equals 2 kips. And then once again, I just plugged it into my equation. It's pretty straightforward. I plugged in my positive 2 kips times the length, which is 150, over pi r squared times E, and I got this answer right here. And then for the final section, instead of going all the way from point A to cutting somewhere here, I just started from this end because it's way more simple. So I cut it right here, and I got N equals 6 kips. So once again, I took my equation, plugged in my 6 kips, times the 100 inches, which is our length, times pi r squared, times E, and I got 0.1697 inches. And for our final answer, all we have to do is sum all of those together, and we get the displacement from point A to point D is -0.1105 inches. Pretty straightforward.